here are the the exercises that I will propose. I will begin with a very short introduction, just to give you an idea of what Unitex is, just the main functionality, and then we will go to the exercises, and perhaps we will alternate between general presentation and exercises. So, local grammar graphs, they are the main language resource which is used with Unitex. So presenting Unitex or local grammar graphs, it's roughly the same thing. So first I will present the notion of concordance, then local grammars, and then the main structure in the main means of organizing a local grammar is subgraphs. So how to invoke a subgraph. Then lexical masks, which are ways to make queries about words or about multi-word units, and then to show dictionaries. So concordance, maybe all of you know that better than I. Concordance is displaying a list of occurrences of some form in some corpus with a context of one line for each occurrence. So here, concordance of one word, which is major. So there are many concordances who are systems that produce concordances. Unitex GramLab is one of them. What is the specificity of Unitex GramLab is that it allows for diversity in the targets, in the occurrences that are found in the corpus. So here you have more diverse list of military grades. So diversity and also sequences. Here a sequence of 2 words. So concordances are used to explore linguistic phenomena and also to explore literary texts. So this objective is general to all concordances. I think that the major criterion of quality of the concordance is the query language, which allows you to express your queries. So Unitex adopted as a query language graphs, which are a way of allowing at the same time diversity in the targets and sequences. Okay, now we are ready for the first exercise. We will begin without graphs, with just a simple query that we will write on the system, just to check that you have Unitex properly installed on your machine. So just to show you how it works, I will launch Unitex. In English, here you can choose the language. The first step will be to open a corpus. So use the text menu, open, and then it will open in the corpus folder where you have the different texts that you can open. Sometimes you have to check the types of the files if you can't see anything displayed here. I choose Ivanhoe, and then I am asked to preprocess the text, so yes, and I accept all the default configurations. Go. And now the text is ready for querying. The menu to launch a query is the text menu again, locate pattern, and here I will type in the regular expression field the pattern that I want to find. Okay, for example, the word eyes. Here you have a setting either to stop after 200 matches, which would be the case if you have really a query that will find many occurrences. But my advice is rather to use the index all occurrences in text setting and search. I have 54 matches. Okay, and then build concordance. Okay, so it's your turn. Okay, so I assume everybody has Unitex installed on your machine. Please, can you tell me when you are okay or when you are facing problems?
Have you seen, Eric, have you seen in the chat that some people responded that they have managed to get the concordances?
Yes, I saw. I have two answers.
Well, if two of them have managed, then we can suppose that everybody else.
Yes, from here I also can see several concordances on screen. Thank you.
Okay, good. So let's go on, except if somebody has questions or faces problems. So let's go back to the presentation. So now the next step is to make graphs. To obtain this style of concordance where the targets are expressions with at the same time diversity and a sequence of words. How do we do that? Here you have a graph a graph is made of paths from the initial box to the terminal box, and in a path where you follow the arrows, you have the description of something that will become a query. So here, dates with the month, which is mandatory in this query. The only mandatory element is the month and the number, which will be the number of the day. The name of the day is optional, and then this will be the number of the year. Okay. And with this graph, we obtain this type of concordance. Finite automata are equivalent to regular expressions. I'm saying that in case you know regular expressions better than finite automata, which would be the case if you are used to other concordances. So here's a graph. The relation between graphs and automata is that a graph takes the mathematical form of an automaton. So this is at the same time a graph and an automaton. This graph will recognize the interjection ha or ha because of the loop, ha, any number of has, okay, with a terminal exclamation. This is equivalent to a regular expression. If you are used to regular expressions, you will know the use of the star, which means repetition of ha 0 or more times. Now, here, the complexity of the regular expression is roughly the same as the complexity of the graph. But in the graph, if we use more the possibilities in graphs of diversity in each part, here 7, here 12, and in the length of the sequence, the regular expression equivalent to the graph will become too large. A regular expression is readable if it can be written in one line, but as soon as it has to be written in 2 lines, it becomes unreadable. This is why Unitex users use graphs as soon as the query becomes too complex. Okay, so this is the case here. So how to make graphs for indexation, information extraction, annotation, in addition to making concordances. You use the FS graph menu in Unitex. Here, FS graph menu, and new to create a new graph, open to open an existing graph. And first step is to create a box. Just use Control-click in an empty space where you want to create the box. Fill in the field above the graph and validate with Enter. So, new graph. Control-click in the empty space. Write the word you want to find in the text and validate. Okay, so I have created a box which appears in red because it's not linked with the other elements. Second step, create a transition between an existing box and another one. Click once on the source box, click once on the target box. This doesn't look like a box, but it is one. I click on the horizontal bar, and then I click on my box again. Now my box appears in black because it's linked to the rest of the graph. Now we can select a box by clicking once on it. It becomes blue and it becomes editable. Okay. I can edit it in the regular expression in the field above the graph. How to unselect a box? Click on the white background of the graph. If you double click on a box, this is the same as clicking twice. So this creates a transition from the box back to it. So it will create a loop like in Ha in my preceding example. And the same operation will remove the loop. We can select several boxes at the same time by drawing a rectangle around them, and then you can move, delete, copy, paste them together. To show that, I will create another box. I selected both boxes, and by clicking on another box, it will be the equivalent of clicking first on this and then on this, and clicking first on this and then on this. So it changes the transitions. Now, how to delete a box? Select it, press delete, and validate with enter. Delete, enter. You have an undo here. You have an undo button, which allows you to change your mind, and a redo to change your mind again. The initial and final boxes, which are the initial is the arrow on the left, and the final box is the square on the right. You cannot remove them, and you cannot create new ones, because a graph has to have only one of them, one of each. And I already showed how to delete a transition. It's the same steps as to create one. Click once on the source box, click once on the target box, and if the transition doesn't exist, it creates it. If it exists, it will delete it. So now it's your turn to make graphs. So I suggested a local grammar graph to recognize at the same time Lady Rowena, Wilfred, and Wilfred of Ivanhoe. So you can make 3 boxes in parallel to recognize any of them. Your turn.
Hello, Eric. Do you hear me?
Yes.
Sorry, I have been having some problems with my Unitex.
Mhm.
Somehow I got it uninstalled yesterday, so I'm not really sure. I'm trying to follow your steps from this PDF that you're showing, and I don't see, when I've launched my GramLab, I don't see any text menu or option to click. Can you just tell me what are the first, like the 0 steps that I'm missing here?
Perhaps you opened in the GramLab form instead of the Unitex form.
Okay.
There are two different interfaces. Be sure that you use Unitex instead of GramLab, and then you will have the same menu as us.
Okay.
And perhaps you can share your screen with us.
Mm-hmm. Just give me a second, please. Okay, so can you see?
Yes.
Okay, I think so. This is GramLab, so that's definitely not what I need. Now, is this it? Okay? See, I see text here.
Yes. Okay.
Okay, and I need to unzip the folder from GitHub.
Pardon?
Do I need to unzip the folder from GitHub, TS Belgrade? Is that what I need to get the texts?
Normally the texts are already in the corpus folder. Try a text open.
Okay. Oh, okay, here it is.
Yes.
Okay, thanks. I think I will manage from here.
Mm.
Thank you.
So perhaps when one of you has the concordance, you can share your screen.
So should we click anything afterwards or just create the graph?
Oh yes, I didn't show that. Sorry, I will. I forgot to show you how to launch the graph. So I will share again my screen. Thanks for mentioning this. So once you have a graph, you use the text locate pattern menu as as with the regular expression before, but then instead of the regular expression field, you will use the graph field. You set the graph by clicking on the set button, and you choose your graph. To do that, you have to first to give a name to your graph. Of course, it has to be saved. So you do this with the fs graph save as menu. Here my graph is meaningless, but so I will save it as meaningless. Okay, now I can use it in the locate pattern graph field by setting it open and then click on search to see to generate the concordance. Okay.
Text, okay.
in the Unitex folder, you have a special place for graphs. I will show you the organization of the Unitex folder. Here. The Unitex folder contains a folder for each language. So let's see the English folder. And in this folder, you have a special folder, subfolder for graphs, and another one for the text here, corpus. Please save your graphs in the graph folder. It's the simplest. Otherwise, because whenever you use the FS graph open menu, it will automatically open the graphs folder.
Can we just have a few more minutes here because people are a bit confused. The graph that is now on screen is not connected, so they made actually something like this. Yes, so graph for please can you see graph should be connected like this. You have a first start. And then from this graph, then you can apply concordances. Can we just, yes, something like this is a complete graph. That's why you have an error. Okay, just a minute to go through the computers here and check if they did everything right. Okay.
Okay, I'm waiting. Once one of you has the concordance, please share your screen.
Okay, should I just share it?
Yes, please.
Okay, I'll try to do that. Okay, now this is just a graph. Is this what it's supposed to look like?
Exactly. You can manage with the settings, you can manage the order of the occurrences. Here, the occurrences are sorted according to the central part. So you have all the Lady Rowenas before all the Wilfreds.
Mm-hmm.
You can manage this if you use the text menu.
Mm-hmm.
Text menu, and you have located sequences.
Mm-hmm.
And then before clicking on build concordance again, you can change the center left setting just above build concordance. You have, yes, you can choose, for example, text order, which will show the occurrences in the chronological order of occurrence in the text, and then build concordance.
Okay, yeah, that makes more sense.
Mm-hmm. Well, it depends of what you need. You can also sort according to the left context, to the end of the left context, or to the beginning of the right context. There are several combinations. It was located sequences.
Ah, yeah, look. Okay. Ah, sorry. Okay. Great. Ah. And what is right?
Right center means that the primary sort will be on the beginning of the right context. And then for the occurrences with the same, exactly the same right context, it will be sorted according to the center.
But what's the right
And
I'm
so
not sure I understand, because I have them one above the other, so I don't.
Mm-hmm. The right context is what you have in black just on the right of the occurrences.
Okay.
So it's alphabetically sorted, so it begins with A and then D, F, F, H, H.
Okay.
Okay, now perhaps we can have feedback from the other trainees.
Hi, excuse me.
Mm-hmm.
I have a question. So I managed to get Lady Rowena concordances, but how do I get all of them? So for all three names, let's say. I didn't manage to follow that.
Tamara, can you show us your graph?
Yes, sure. Yeah.
Here you have three paths in the graph. Each path recognizes one of the targets of the query. And if your graph is more or less this way and you use it as a query, it should find all three targets.
Okay, I'll try. Thank you.
Oops. Okay, should I stop sharing or?
Perhaps yes. I think that everybody has seen the graph. Thank you.
Sure.
In this example, there is no punctuation in the sequences, but be careful that in other sequences, if there is some punctuation inside the sequence, it has to appear in the graph. For example, if I'm looking for a sequence with a comma and I insert a comma in the graph, it will find the occurrences only if there is the comma. And if I don't insert the comma, it will find the sequences only if there is no comma. That's the difference with Google, with the Google queries, where punctuation is neglected.
Thank you. I think that we can go on. People here catch up now. All of them have results. Thank you.
Okay, so if there are no questions, let's go on. So we will now see more complex graphs. When a graph becomes more complex, it's convenient to split it into several parts. The idea is more or less that each part can fill a screen. And if what you are looking for needs several screens, then you divide it into several graphs. And one of these graphs has to be able to invoke the others. And so the others will be called subgraphs. An example here with the sequence to be more of a something, to be less of a problem and more of a threat. Okay, so this is a description of this grammatical pattern. One of the problems to find this pattern in text is the adverb in the middle. You quite often can have is probably more of a problem. This set of three adverbs is more or less simplistic. If I want to recognize more diverse adverbs or adverbial expressions, I should develop more this part of the graph. And if it takes too much place, it's better to make the description of the adverbial part in a subgraph. This way. I replaced the description of the adverbial part by the invocation to a subgraph, which I called ADV. The box appears in gray because it's a special box in the sense that it invokes a subgraph. And this invocation is equivalent to substituting the complete subgraph for the invocation node. So this is a little more developed form of the description of the adverbs. In this form, I can have not only probably, still, and much, but I also can have still much, still probably, probably still, and a few others. The objective of this form is to use the same graph in various contexts, because this ADV subgraph can be probably used in dozens of other queries, and also to distribute the description in several graphs if the description in only one graph would be too complicated. So to do that, you just need to know how to make a box that invokes an existing subgraph. To do this, the secret is just to begin the content of the box with a column, and then the name of the subgraph. Why does it appear in red? What did I do? My column did not appear. Yes. You were right, Ranka, because it was not saved. So with this trick, I can invoke a subgraph just by invoking its name with a column before. This invocation of a subgraph by a graph opens up many possibilities. For example, a graph can invoke itself. This graph recognizes forms of the type of something with some determiners before, and with possibly nominal adjunct after it. And this nominal adjunct prepositional adjunct can take the form of a prepositional phrase in of. So it will invoke itself. Okay, this is allowed by the formalism. This concept of a graph that is able to call subgraphs has been named local grammar. Why? Why local? It has nothing to do with the locations, just because it will describe a part of the syntax of the language, which is limited to a small part. So local grammar graphs. It's a type of language resources. It's used to recognize and process expressions, and it can be included in a production chain in language processing. This is not new. Here you have a selection of references, bibliographical references about the creation of the notion of local grammar graphs. As you can see, it has had the time to get mature. A few tricks to make your graphs less awful than this one. This graph evokes spaghetti dish or spider web, which makes it little readable. You can easily miss an error in it. How can we make it more readable? First possibility is with empty nodes. Here, by creating two empty nodes, which are intermediate nodes between these boxes and these boxes, I reduce the number of different transitions, which makes the graph less tiring to create and more readable. Another trick is to include several forms in parallel into a single box. Here, instead of having 3 boxes in parallel, I include them in a single box, and the same with the 3 verbs and the 2 adverbs. It's a graphical convention. To obtain this, just select the box, type the content of the first line, type plus, and then the content of the next line, and plus, and so on. And it will appear in this way. Perhaps just to show you, I think we have time for this. Plus. Oh, sorry. And you don't need the spaces around the plus signs. Okay, also to show you how to make an empty box. When you create a box, it already comes with this symbol with the uppercase E, which means empty. So if I don't edit this symbol, the box will remain empty. Okay, so really nothing to do to, practically nothing to do to create an empty box. Now, for the next exercise, we will also begin to use lexical masks, which are a way to target several forms instead of one, because the same meaning can be conveyed by words with different suffixes, like in the examples of collect, collects, collected, collecting, collector, collection. So this is to increase the recall of the graph. The recall is the capacity to find occurrences. Increase the recall of the graph automatically without.
Cvetana, do you hear Eric?
No, Eric, we can't hear you. Eric, we can't hear you.
And here, can you hear me again?
You have now some time to do. Who needs help while Biljana is here to help you? Do you need over there help? Don't worry, we are using here times for hands-on.
Can you hear me again?
Yes, we
Yes.
can hear you now.
Okay.
Now we can hear you.
So, do you want to report your problems, or may I go on a few slides about techniques?
Please, we didn't hear you last few minutes. So if you can just
so
repeat, please.
Did you hear me when I created the empty box?
Empty box, yes. And when you merged with the plus sign.
Okay. So the new element will be lexical masks, which are a way to increase the recall
Please
of...
share the screen if we.
Ah, sorry. Okay, so lexical masks will be a way to, with one query, to target several forms. For example, several forms with different suffixes. We are doing this in this graph, where, as compared with the preceding graph, which was with is, was, be, in three boxes or in one box, now we will have it with a single query of the verb be with the angles. This is because Unitex is based on dictionaries, and we have a dictionary. We are using a dictionary that says us that is, was, and be are forms of the lemma be. Okay, so by inserting the angles, I specify that what is targeted by the query is not only the lemma be as a form, but all the inflected forms of the lemma be. Okay, you can use this either in the regular expression field or in boxes of a graph. Second example, collect with the angles will automatically include the inflected forms of the verb collect, which are collects, collected, and collecting. It will not include the derived form, like collection, collector, collective, collectivism, because the meaning can derive from the meaning of the lemma. So the notion of lemma is taken with the in the sense of inflection and not of derivation. Please interrupt me for any question. So this was our first form of lexical mask. The second form will be with part of speech. Here you can see in this graph, instead of listing probably, still, and other adverbs, I will use the dictionary that tells me which words are adverbs. So I use the ADV symbol which represents all adverbs, and the angles to specify that what I mean is not ADV as a literal form, but as the representation of a part of speech. Okay, so the same angles can be used either with lemmas or with parts of speech, and also with any other feature represented in the dictionary, except inflectional features. And here are a few other lexical masks, which are special lexical masks. For example, word for any word, first with any word with the uppercase first letter, NB for sequence of digits. And you will have others in the manual. I will share for you the web address of the manual. So just to, as a conclusion about lexical masks, a lexical mask is a key that will recognize a set of linguistic forms on the basis of formal features represented in the dictionary, and they can be used in graphs and regular expressions. So the web address of the manual is this. You can download and find the information about lexical masks and the details of how to use them. So let's get back to the exercises. Now you can produce a concordance of these forms with an adjective of the geographical origin and a selection of names which are frequent in Ivanhoe to be able to use all the tricks I taught you about graphs. Your turn. Unless you have questions. And again, you can share your screen once you obtain the concordance.
Some are managed, but some are still trying.
perhaps you can report your problems if we can help you.
No, here we are managing, but one by one. Okay. Jel većina da nastavimo? Should we continue? I think that we can continue now.
Okay.
Sorry, I got an error message, but I'm not sure. Should I share my screen?
That's best.
Okay.
I'm not sure what I did. Ah, sorry.
This is because the transition between the first box and the second box, in fact, is from the second to the first.
Ah, okay.
So,
I see. Okay.
yes. And then you can delete the transition from the second to the first by clicking first on the second and second on the first.
Okay.
Yes,
Okay.
now
Great.
it should work.
Okay, thank you.
This is a very important trick.
Yes.
Okay, now to be able to use lexical masks professionally, the secret is to look at the dictionaries of the text. If you look at your screen, your Unitex screen, you should see in the bottom word lists window, a word lists icon. If you click on this icon, you can see the dictionary of the text, which is the dictionary of the words occurring in the text. Okay, can make it larger to be able to explore better. So it's in three parts. On the left, on the upper left, you have the lexical entries for the simple words in the text. Below left, for the multi-word units occurring in the text. And on the right, for the words in the text not found in the dictionaries. By looking at these entries, you can understand the structure of an entry of the Unitex style dictionary. The blue part is the inflected form, the one that is found in the text, except that in the text it can be uppercase or mixture of uppercase and lowercase. In the dictionary, if it can be lowercase, it's written only in lowercase. You have uppercase only when the uppercase is mandatory. So this is the blue part. Now we have a comma and the red part, which is the lemma of the inflected form described in the entry. So the lemma of goals is goal. And then you have a dot and and then you have a dot and inflectional features here, part of speech, and human noun, abstract noun, concrete noun, and so on. And after the colon, you have the inflectional features, here plural. With a verb, you have several inflectional features, present, third person, singular. Each of these elements can be included in a query, okay, with the angles, in case it's not only the inflected form. Now, I'm not finished for the last exercise. for the last exercise, which is producing a new version of the text where expressions are tagged with the XML style tags. I need to show you how to do that. So I make a new graph where I, for example, want to tag names of countries. So I make a graph that recognizes names of countries, and I want to create a new version of the text where these occurrences will be tagged by an opening tag and a closing tag, which will take the form of, here I'm making them mandatory, because the early path that goes from the beginning to the end will pass through these tags. So if I wrote here the form of the tag, for example, country name, this would be understood as a query. I don't want it to be understood as a query. I want it to be understood as an insertion in the text. So the trick to do that is to leave an empty part in the box with the empty symbol and include a slash to make a limit between the left part, which is the query, which is empty for this box, and the right part, which is the insertion. And by validating, it appears in this way, an empty box with an output below. I will do the same with the other box, but with a slash to show that it's a closing tag. And now, if I save it, and if I apply it, text locate pattern, if I apply it, it will insert the tags in the new version. To do that, I need to change the settings of the grammar outputs. The grammar outputs are these that I just inserted. I want the system to merge them with input text. All the input text will be retained and the outputs will be inserted. So search. And here, instead of building a concordance, I will use the modify text part of this window. And I will give a new name for the new version of the text. I don't want to overwrite the existing text. I want to create a new version, which will be Ivanhoe tagged .txt, and I click go. And now to see the file that has been created, I can use, for example, the file edition menu, open text file, Ivanhoe tagged, and then I can look for my tags to check they have been created. I'm not sure these countries exist in the text. Yes, here you can see country name, England, country name. Okay. Any questions about this process?
Not
If
right now.
Mhm. If there are no questions, you can now proceed to the last part of my training, which is produce with a transducer. A transducer is just a graph with outputs. Okay, produce a transducer with a transducer, a new version of the text where these expressions are tagged geo for the geographical adjective and person for the human name. Okay.
Should those be two different transducers?
No, just one transducer, because in your graph, you have two parts. You have the part for the adjective and the part for the noun. And you will make a graph that recognizes both and will tag the first with these two tags and the second with these two tags. So the adjective will be tagged only if it's associated with the human name. Am I clear?
Probably, maybe just me. So it should like continue one into another. So we should have these two empty spots for geo, and then
Yes. And then
continue on with two that have person.
Yes, in the end of the path.
Okay, I think I got it.
Mhm.
We'll try.
Sorry, I don't think I quite understand. So in the example that you gave a couple of examples like England, Serbia, Poland, etc.
Mhm.
But is there a placeholder for person or for human or something?
No, this
Like
is
how
not.
can I?
This was just an example where I wanted to tag place names. Okay, the
Mhm.
exercise is not to tag place names, but to tag the occurrences that you found with your graph in exercise 4.
Ah, okay.
Okay.
Okay, thanks.
Perhaps if some of you has already made the graph, you can share your screen to help the other trainees.
Maybe somebody can share not the complete graph, just how have they started to do it, to see if we can maybe help them. Can somebody just show what have they done? Maybe Tamara?
Yeah, sure. Yeah, happy to do it. Just finished, but I haven't tried it out yet.
Okay, just to see how it looks.
Mhm. Can you see it?
Yes, yes.
Perfect.
It looks perfect.
Okay, great. Okay, I'll try it out then.
Mm.
So,
Yes, locate pattern.
yes, that's the one. Okay. And now I need to set it. I didn't save it yet. Okay.
Yes,
Yes,
you
I did.
save it as I will do. Okay.
Is that the FST2 or the
No,
GRF?
GRF.
Mhm.
But you did not save it yet.
Yes, it's saved.
I did. Yeah, just now.
Yes, it's saved.
Ah, okay, sorry.
And I go to merge with
Merge
Merge,
with
yes.
input.
Mhm.
Yes. Oh, and now you can build concordances. Build. Okay.
Okay, but shouldn't
No,
wasn't it-
no. Just build concordances.
okay.
You
To
can
see
do
what you have
modify
got.
text later.
Okay.
Okay, so now you see what you will get when you change your text.
Mm-hmm.
But in fact, it's not what I meant. In fact, what I meant was to tag the sequences of geographical adjective and a human name. What you did was tagging separately any occurrence, but
You can now very easily change the graph to obtain
Mhm.
the sequence. Just you have to change the path. So from this tag where you have the
yes,
this
one.
end, you will connect with the beginning of the person. Yes, this and this, and then delete the one that goes directly from end geo to the end of the graph.
Yes. Mm-hmm.
Yes. And now save.
Okay. Mm-hmm.
I say, and then you will get the sequence.
Oh, that's great. Okay.
Okay, now you have, of course, much less matches. Build concordances, and now you see you have some. Yes.
Oh, this is really great. Oops. Okay.
When you click on an occurrence, it will show this occurrence in the complete text.
Yes. Mm-hmm. Oh, this is very practical.
And now you can make the modified version of the text by going back to text and located sequences, and then result txt file.
Do I set file or go?
Go.
But okay.
Oh, sorry.
You didn't put the extension of the file, but okay, you will get something.
And now to see it, you can use the file edition. No, file edition.
Yes.
Open. text files.
Mm.
You have to choose all files because
All files, because you didn't put this all files.
Ah, yes. And should it be SNT? No.
This one, I think, without anything.
click
This
OK.
is not necessarily the text.
Yes,
file
because it's a
first.
new file.
Ah, okay.
And
Okay,
then
so I should have put.
with the binoculars,
Binoculars to try to find this, what you have changed. Try to find geo. But with the, yes, like
Yes.
that, for
Mhm.
instance.
and then you have one on the last line of the window.
Yes, you see last line.
Uh-huh.
Yes,
Yes.
Saxon princess.
Oh, great. But it doesn't highlight where I.
No,
Mm,
it's
no.
it's
Okay.
just a very simple editor.
Okay. Okay.
It's just to go out to look the notepad or something like that. You can use but it's not very sophisticated.
Okay. So what I should have done here is set file, right?
But put it's better to put the extension txt that you know that it's
Okay.
TXT.
Okay.
But it's not
So
a big
that-
deal.
Okay. 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 Thank you.
Okay, thank you, Tamara.
Thank you, Tamara. You were great.
Any questions by other trainees or by anyone? Okay, so it was a pleasure to work with you for this tutorial. If you have any feedback or suggestions about this tutorial, please feel free to email me. And if there are no other questions, it's coffee break.
Thank you, Eric, very much. Here is still a working atmosphere. Some of them have done nearly as good as Tamara, not so good, but we will have some time for exercising now. But thank you very much. And I'm sure that you will have new users in this session. I would just like to add that for several languages, we will see later on Unitex site, and you can see for I think all your languages, for persons that are present here, you have resources for your own language, and everyone can test some of your own novels from your LTEC collection with Unitex dictionary for that language. Thank you very much.
Thank you.
Okay, before the break, we have the break 15 minutes, I think.
Yes.
Yes. Well, I would like.
I think now it's time to continue. And now we have a pleasure to hear our dear Professor Cvetana Krstev with the named entity recognition story in Unitex.
Thank you. First of all, I'm really sorry that I'm online, distant from everybody else, but as you know very well the reason why is it so. I'm still not very confident to mix with too much people. Well, it is the topic of my presentation is the how we can use Unitex to solve the name entity recognition problem. But before I do that, I would like to make a short introduction. In these 3 days, we have heard some details about some wonderful sub-collections of this LTEC corpus. And I feel that it would be really pity that we don't hear something about our sub-collection, Serbian sub-collection, that I also find really wonderful. So I hope you will not mind that before starting my presentation, that I will say a few words about our presentation. Now I will share my screen. I hope share, okay, but I will now go here. Do you see the distant reading page? Ranka?
Yes.
Yes.
Yes. Okay, I will, so that you can see the whole page. You have seen this distant reading page several times during these few days, and probably you have also seen it before. It gives the present status of the LTEC collection and lists all the languages that are preparing or have prepared their sub-corpus. You see the Serbian is here, somewhere at the end of the list, and you see that it is among collections that have a complete sub-collection with 100 novels. There you see also the other parameters that are important to see how well balanced is this corpus. You see that this score that was invented to somehow shows in one number how good good. I don't want to use that word because it seems that some sub-collections are good and the others are not good. It's only to show to what degree it is done according to this balance criteria. So you see that we have some wonderful sub-collections like English, French, Hungarian that have scored 100 or even above. But our collection is something above 80. So you see, it's not so well balanced as the other sub-collections. If I click here, you will get this nice plot, mosaic plot, that will show you why our more easily, why our sub-collection is not so well balanced. First of all, you see that these rows parts are really very, very small. It means that we don't have so many women authors. Actually, only 8 works written by women among 100, 8 works, and these were written by 4 different women. Why is it so? It is certainly not because we didn't want to put women authors in our corpus. Absolutely not. It is because that time period that is covered by LTEC corpus, women in Serbia were occupied by some other things, and they didn't write books. Well, to put it simple, like that. And even if they wrote something, it was most probably poetry or culinary books or some books to help women how to manage their household or something like that, and not the novels. The other things that we see in this plot is that this part covering long novels is really also not well represented. We only have 6 novels that are long, according to the criteria chosen, which was, as Christoph said, more or less arbitrary, but anyway, the same for every sub-collections, is more than 100,000 words. Why is it so? There are 2 reasons. First, it seems that at that time period, the long novels were not so popular in Serbia. There were not so many long novels, much more medium or even short. And the other is characteristic of language. It is well known that languages like Slavic languages with high inflection, they have somehow expressed themselves with less words. we don't use determinants, we don't use so many prepositions because there is inflections. So somehow in that very formal criteria, a number of words, our novels are shorter. And then there is a third reason. The third reason is that you almost don't see the first time period, the first time slot. The first time slot is from 1840 to 1860. You don't see it because there are only 2 novels in that time period. It is due to many reasons, mostly historical reasons, because it's, again, Serbs were preoccupied with many other things at that time period, and also because of the language reform that took place at that time. So, for instance, for that time period, we could find more novels, but they were written in a language of before the reform. It's of no use today. Nobody understands, simply to put it like that. And that novels were not transliterated or adapted to modern language. So simply we cannot use them. What else can I say about our sub-collection? Is that we have both sub-collections completed, both level 1 and level 2, they are completed with 100 novels, and we also have some extension with 20 more novels. The level 2 has not a complete morphosyntactic tagging, but part of speech and lemma, and it uses for named entity tagging 7 categories, as was agreed by the working group 2, and all 7 of them are used for our sub-collection. So, for instance, here, if you see here, this is level 2, you will see that we have that is our GitHub with all the novels. You will see that we have all 100 novels there, and then if you want to look at the statistics, there is a table that will say for all these categories how many of entities were tagged for each of these category in each of these novels. Well, I wouldn't go more into detail. I would just at the end want to say that we have put a lot of effort. Our team has put a lot of effort to compile this corpus. But when I say effort, I don't mean that we suffered or something like that. I think that we enjoyed the most part of our work. We enjoyed. I'm sure that I have enjoyed, but I think that the others also. Why we had to put so much effort, because of 120 novels that we have now in the main and extended sub-collections, except 4 of them, they were not digitized. We have done it from the scratch. So it means that we retrieved the novels from libraries, that we did OCR, a correction that was done in 3 steps, and then all the tagging and everything else. So a lot of work. In this work, we had the help of our volunteers. In a total, 25 volunteers were involved in this our endeavor. Some of them read many books, some of them just one. It depends, of course, of time that they could devote to the whole project. I'm happy to say that here today, except me and Ranka, that we both read a number of novels, I see 4 of our volunteers that are Biljana Rujević, who is present here, Aleksandra Marković, Milica Nešić, and Tamara Radak. They all 4 of them helped in our work, and I'm grateful for all of them. Ranka and me, we were the main team leaders. I was mainly a leader for the level 1 production, and Ranka was the team leader for the level 2 production. Well, with that, I will stop with this presentation of our LTEC collection, and I hope that many of you will use it and enjoy in using it, and send us a feedback of your work on this work using this sub-collection. And now I will go back to my main presentation, and that is Unitex for named entity recognition. This presentation was prepared by me and my colleague Denis Maurel from the university in Tours. So, what will I present in this talk? First of all, why is Unitex so important or suitable for named entity recognition? And why are dictionaries important? Why do we use dictionaries to solve this task? And why do we use graphs to solve this task? And what can graphs in Unitex do? We'll say about more advanced feature of graphs in Unitex that can help us solve this task, and why using cascades of graphs. So, why using Unitex for named entity recognition? Unitex will help us to produce a lexicon-based and rule-based systems. It enables writing rules that rely on information from dictionaries, which is important and which I will show on the next slides. And these rules are in the form of finite state transducers, even augmented transition networks. Those are the terms from the formal grammars. I will not go into details here. Intuitive use of these transducers is enough for our purposes. And these rules are sometimes called local grammars, as Eric already explained. Sometimes are called shallow parsers because they are not intended to do the complete syntactic parsing of a sentence, but in some local context. What are the advantages of these lexicon-based and rule-based systems? One of the advantages that some people see as advantage and some people don't think it is important. I think it is important. It is that they are not black boxes. I mean, you always know why something is done in certain way, and if it's not doing what you think it should, you know how to react, to write some new rule or to use better dictionaries. And these lexicon-based and rule-based systems are unavoidable or very important for preparation of training sets for machine learning systems. Well, now I will say something about dictionaries. What is in dictionaries that can help in named entity recognition? Here we see first is one entry from the French dictionary, and then is the entry from the Serbian dictionary. Those are entries from the dictionaries used in the Unitex environment. First is French, Jeanne d'Arc, and it has some properties that go after comma. These properties, or we call them markers. First says that it is a noun, that it is a proper name, that it is an anthroponym, a proper name of a human being for one individual, not for several persons, and it is a famous person. And then we say it is the same person, but as we call it in Serbian, Jovanka or Lajanka, and we have a different set of markers, but saying more or less the same, that it is a noun, proper name for a human being, that it is name given to a human being, but not particularly, not the first name, not the second surname, but just a name, as is the case in this Jovan Korlanka. You can't say that she's simply known with this name, and she's a famous person and a historical person, so comes from the domain of history. What we see here is that the dictionaries use the same, for French and Serbian, the same format, but the information need not be the same. The different set of markers can be used as the developer of dictionary finds the most suitable for the language purpose or whatever. Here we see something similar. Babel Mandeb, as written in French, more or less the same in Serbian, but the markers are now different. We have in French marker that it is a noun, a proper name, toponym, and a hydronym. And in Serbian, it's different markers are not the same, but saying more or less the same thing, that it is a noun, a proper name, a toponym, a hydronym, with addition that it is a straight. What kind of hydronym? It is a straight. And now we have another entry, again for the same entity in French and Serbian. It is the European Central Bank, but said differently in French and Serbian, and with the different markers. For instance, in Serbian, it says that it is a noun, a proper name, organization from the domain on finances, and it has an acronym, ACB. That's the acronym of this organization in Serbia. But then we have another entries in a dictionary that can help in named entities. Before we saw the entities that have a very strict referent. Now we have proper names, but the referent is not so strict because we have Eric, for instance, in French that says that it is a prénom, a name, and here it is with addition of some grammatical elements that needed be here, but it doesn't matter. And we see that it can be written in two different ways, with accent and without, so there are two entries. But of course, there are many people that are called Eric in France or somewhere else, but nevertheless, that are proper names and then can help in retrieving named entities referring to people. In Serbian, we have different markers. For instance, Marko is a noun, a proper name for a human being, and it is the first name. Vitas, it is the noun, the proper name for humans, and it is the surname. But there are other things in dictionaries that can also help us in solving the problem of name entity recognition. For instance, in French dictionary, there are entries like professeur, directeur, roi for professions, and they have the marker that are nouns for professions. The corresponding entries in Serbian would be professor. It says that it is a human being and it is a profession. Director, it misses the marker hum here, but it also has the marker hum for a human being, but it is not a profession, it is a position. And kralj, it is the marker for human being, and it is a title. So we again see that the markers are not the same, but it doesn't matter. It can help solving the problem in any case. And there are other things that are also helpful. For instance, some common words, but that can be useful for solving the problem of named entity recognition, like May, Sunday, after, every day, and so on. And they are of different part of speech. They can be nouns, preposition, adverbs, and so on. And now we come to the next question. And that next question is, can a named entity recognition system rely on dictionaries only. Just use the dictionaries and, for instance, some lexical masks, as you have seen previously, Eric has showed you lexical masks. Would it be enough to solve the named entity recognition problem in text, but to have a high recall and precision? First, for instance, in French, in Serbian, we could use these lexical marks to, that's the first line, to retrieve hydronyms and to retrieve organizations. That's the second line in this table. And to recognize person's full name, to use this sequence of two lexical masks in, we see the example in French and Serbian. Will this solve our problem? Well, the answer is not. Its dictionaries are very helpful, but they are not enough. Why are they not enough? First of all, dictionaries can never cover all named entities. It is not possible. You will always in a text come to some names of people that you don't have in dictionaries, some unusual, not so usual names. Also some toponyms of some faraway places that you don't have in dictionaries. And not to say organization names, because as you know, organizations all the time, you have some new organizations, and of course you can't have them all in a dictionary. So the recall drops. And the problem of recall and the problem of inadequacy of dictionaries is especially true for temporal expressions that are usually, and other sort of expressions that are usually thought to be named entities as well, not in the proper sense, but named entities anyway. In temporal expression, you have various formats of numeral expressions, then for measure, money, and so on, and they use numerals, either like digits or words or their combinations. So these all combinations of numerals that can be very different values, you simply cannot put them in dictionaries. And the third problem is that many word forms are ambiguous, and that may lead to false recognitions. And of course, the precision will drop if you rely on dictionaries only. For instance, this is the graph that Eric has showed several times. So it shows that you cannot describe this with the dictionary. Why? You have entries like Monday, Tuesday, Wednesday, okay, January, February, March, okay. You will have, if you want to put that in a dictionary, you have to make all the combinations of this, and only months, and then combinations with months and the name of the day. But what to do with the numbers that follow? You can have all the combinations with the dates and month, with the dates and then the year, which one? It's simply impossible to put, and even if it would be possible, it is not very convenient. And then ambiguities. Ambiguities of the proper names as well as the other common names, but now we concentrate on proper names. There are a lot of ambiguities. We will show just a few of them, and then ambiguities are in French as well as in Serbian, as well as in any other language. For instance, Balkan. Those are, for instance, Balkan is inherent ambiguity, because it is the word used both for a mountain, exists a mountain, and the super region that includes several countries. Congo also, it's the name of the river and the country. But then you have other ambiguities. For instance, Aden can be a city and a personal name. Amazon, first it is a river, then in French it can also be ethnonym, but it is also an organization, as we know. In Serbia, I give you an example now from Serbian, but as I say, it's the same for any other language. For instance, Una is river and the feminine name. Sava, which is very important river in Serbia, the most important after Danube, but it is also a masculine name and a very often, frequently used masculine name, but also it can be also a feminine. Jelica is a mountain and a feminine name. Then you have Miloš, that can be first name, but can also be a surname. Then you have ambiguities with common nouns. For instance, you have Višnja, a feminine first name, but it is also common noun, meaning sour cherry. Ali, she's a really very, very difficult case. It is a masculine first name that can be frequently used and a conjunction but. So you have somehow to solve this problem of ambiguity. There is also the ambiguity of forms. This is especially important for Serbian. For instance, you have a masculine name Ivan and then a feminine name Ivana. They are different in nominative case, as you see. But then when you see other cases, you see many of them coincide. Those that coincide have the same color of the background. So you have, for instance, with the orange background, it's the nominative of the feminine name, genitive of the masculine name, and accusative of the masculine name and the vocative of the feminine name. So with forms, ambiguity of forms, it's even more important because there are a lot of names, for instance, first names that come into pairs like this in Serbian. So they will coincide in different cases. Only those that have a white background are exclusively used for feminine or for the masculine name. And now how graphs can help to solve many of these problems. First of all, they can describe different forms that a certain named entity can appear in. For instance, a full name of a person, as it appears in a text, can consist of first name, last name, additional last name, middle name or initial, nickname, and title. If you want to recognize full names, only first name and the last name would be required, and all the others are optional. All the others are optional. How this will help solve the problem of ambiguity? For instance, if you have a Višnja as a feminine name, but you don't know if it is a feminine name or it means sour cherry. But then if you have a last name that follows it, then probably it's not the sour cherry, probably it's the first name and the last name. So we see here one graph that recognizes feminine full personal names in the genitive case. You see, this is quite a complex one graph. You could not describe this with dictionaries. You could not describe this regularly. I mean, you can, but you would get some very long snake for this. But in a graph, you can have a control over everything that is here. So the upper part of graph models the situation when we have first last name and then the first name, the surname and the first name, and the lower part is the first name followed by the surname. What we have this as these red boxes, they are simply not connected, and then we use them as a commentary. And then we see that we have the output. If we recognize something like that, we have a path through the graph from the start to end. We can put this XML-like tags to say it is in genitive feminine full name in the genitive case. And here we see what would be recognized by some of these graphs, not only with this one, but then we have the same for the masculine genitive, and then we say the same for masculine nominative, masculine, etc., etc. So you see what would be recognized. These are names that I took from some texts that were recognized by those graphs in some texts. So you see the case title, first, last, nick, then first, last, hyphen, last, then first, nick, last, then only first, last, but then first, initial, last, etc. So you see that names appear in many different flavors, to say like that, and all that is recognized by graphs. And also, as in Serbian, for instance, it is not so important for French and even less for English. In Serbian, we need to ask for the agreement. That's why we have the separate graph for the genitive case. For instance, if in the case of the masculine name, if you have first name in the genitive case, then the last name has also to be in the genitive case. And this helps solving these problems of ambiguity to a certain degree. Cannot be done completely, but to a certain degree. But how can graphs help, or can they help with false recognitions? And why do we have false recognitions? Well, they can help because some lexical masks can be restricted if there is an unwanted ambiguity. Here is some concordant lines that were obtained with the simple lexical mask that we've seen in some in this table some slides before, trying to recognize hydronyms in a Serbian text. So these are 4 concordance lines. In blue are true positives. So Nišava is really a river in Serbia. Rasina is also a river in Serbia. But then we get completely confused with this oko. Dostigao je oko podne vrh it po rečima, according to the words of many people. So you don't know why we have got that, because those are not rivers, certainly. Why? Oko is a form of oka, which is a river in Russia, but it is also a preposition oko, around, and the form of a noun I. Po is a river in Italy, and also preposition po. So if you use just a simple lexical mask, you will get, can you imagine how many oko and po can be in a Serbian text being prepositions? Many of them. And all of them, if they are by some chance written, and they will be at the beginning of a sentence with the uppercase, first uppercase, then you will get a lot of false recognitions. So you can reject false recognitions by saying, well, I will tag something as a hydronym, but only if it is really only a hydronym and not something else. So this is a lexical mask that recognizes hydronyms. And here is in these green brackets with this negation sign, exclamation mark, which is often used as a negation sign in programming, but only if it is not some other type of proper names or some other part of speech. For instance, it's not a form of verb, preposition, or adverb, or something like that. And we will tag it with the appropriate tags for hydronyms. In this case, in the nominative case. Well, what is this right context? It is called right context, these green brackets. And this right context can be positive or negative. The context can be positive if you want the pattern inside the bracket to match the analyzed text at the current position, or negative otherwise. But surprisingly, the right context can appear, it is called the right context, but it can appear at the beginning of the graph, as in our previous example, in which case it proceeds only so the graph will proceed only if at the current position, when we enter that graph, current position, the pattern inside the bracket is matched, if positive, or not, if negative. So here, for instance, we start to do recognition at some point in text. At this point, we enter the graph, and first we check if what we have found at that position, according to dictionary, is probably a proper noun for country, or proper noun for region, or proper noun for city, and all this listed here. If it is, then we won't continue with this graph at all. So maybe it is hydronym, but if it is ambiguous with something we listed here, it will not continue. But what is the, okay, with this, we will reject po, we will reject oka, okay, oko, which is okay, but that would reject all occurrences of the river Sava, because it is ambiguous with the first name. It will reject all occurrences of the river Kolubara, because Kolubara, when written with the lowercase, is ergonym. It's a trademark of Kol. It will reject all occurrences of the river Gradac, because it is also the name of numerous villages in Serbia, Croatia, Bosnia and Herzegovina, Montenegro, Slovenia, and who knows where else, are also the diminutive of grad. So how can we mend that? We don't want these false recognitions, but also it's not the solution to reject too many matches. So we would like to recover these false recognitions. So what we have here in this graph, first we have lexical mask for hydronyms. They are here, lexical mask for hydronyms. But now we have a left context saying that we will recognize them only if we have the right left context, something that is usually called triggers. We have some word that will trigger or say us that after that, most probably, it cannot be said that it's 100% sure, but most probably we will have a, if it is in dictionary hydronym, really hydronym, then that probably is a hydronym really. What is here? For instance, on the banks of in Serbian, and then something that is tagged as a hydronym, then probably it is really a hydronym. If it is the bridge over, and then something, then probably that something is really a hydronym. So what will be recognized and tagged by this graph? So we see here the examples and the translations. On the other side of the Drina, Drina can also be a feminine personal name. Most preko Dunava, the bridge over the Danube, on the border along the Danube, raft in Belgrade on the Sava, on the banks of the Danube. Okay, Danube would be recognized anyway, it is not ambiguous. But here is Sava and Drina would be rejected. With these left triggers, they would be recovered again. These are hydronyms, those will be inserted tags, and these are the triggers. What is this left context? That's that green asterisk indicates the end of the left context of the expression we want to match. They don't contribute anything so important to the graphs that can be written without this special feature, but they are important for concordances, because if you put this left context or this green asterisk, then you will get concordances listed by hydronyms, and they will not be included in this as a keyword. But in the output in the left context is ignored. So it is only to see the concordances in the way that you would expect to see them without the left context. But then you can do more for recovering false recognitions. You can enter verbs also. So you have here hydronym with verbs in the right context. And then you have, again, here hydronym with the verbs in the left context. So what will be recognized and tagged by this graph? For instance, here we have that the river Tamnava overflowed in the region, and the Timok flooded 300 houses. That's the verbs in the right context. And then you have that she drowned in the Sava, and she jumped into the Sava. That's are verbs in the left context that will help you solve these ambiguities. These are the hydronyms recognized by the lexical mask. This is inserted text, and those are triggers in the right or left context. And what else can you do? You can perform normalization of recognized entities. Sometimes it is useful to normalize the recognized values and pass that value to the output. This can be done for several purposes. For instance, a numerical value in an entity, measures, money, percent, and so on, can be normalized so that you have not numerals written in many different ways, but in some normalized way. Then a recognized date or time expression can be put in normalized form. There are standards that say what is the normalized form of these expressions. And for recognized entities for person, place, and so on, you can put lemma. This last case is again not so important for English and French because personal those names for person and places will not inflect, but in Serbian, for instance, they will inflect, and you would like to get lemma. You see here normalization of numerals for some expressions that can be money expressions or measurement expressions or percentage expressions, and you see that when recognized, their values is put in the normalized form. It is written, for instance, in the first line, it is written 171.1 million euros, but then it is put in a normalized form, how it would be written in a fixed point notation. And also euros is not retained this form, but it is the international acronym for this currency. And so it is done for measurement and for percentage. How it is done, there is a special type of graphs called dictionary graphs, and they were developed for Serbian that are used in the phase of the application of dictionaries, and they assign to each recognized numeral its normalized values, normalized value. Here you have seen the temporal expressions, various temporal expressions, and they have, when recognized, the attributes that say, first of all, type attribute, the type attribute that says what type of temporal expression it is, and then a value that is standardized value, and the standard is time markup language that says what is the how the values of temporal expressions should be normalized. So you see here the normalized values for dates, for time, then for duration, and then for some expressions that say that something is repeated several times, and the appropriate values. And here you see the something for personal names. You can put the personal names, recognize the personal names into the lemma form. For instance, in text you can find Jadranskog mora, and then when you recognize that as location, in this case hydronym, you can put the recognized value in the nominative case, which is Jadransko more, and all the other in all the other cases it's the same. And to do that, there are transducers that perform this normalization, and they rely on the content of dictionaries. In order to do that, we have to have all these entries in dictionaries. Even Mahdi Ahtisaari would have to be in a dictionary, which in case of the Serbian is, because he was at some point important for Serbia. For instance, the entry for Međunarodni monetarni fund, which is International Monetary Fund, has to have a marker saying that MMF is its acronym. So you see, we recognize MMF, but put as a value the complete name, not the acronym, Međunarodni monetarni fund. And in order to work to do that, there has to be in a dictionary marker saying that MMF is actually the acronym of this organization. They also use a special morphological mode and dictionary entry variables. We will see here how it works. Dictionary entry variables and the morphological mode. Here is the simplified graph for the full name, full names in, let's say, in Serbian. These why full names you see here first, followed by last, and in masculine gender and the genitive case. And here you see the reverse order, last first, masculine case, genitive. Here you enter the morphological mode. Here you have enter the morphological mode. And here you see below each entry, morphological mode enables you to go directly to the dictionary of the text, to the specialized dictionaries, and retrieve information from dictionaries. So this F is a variable, dictionary entry variable, that has matched the pattern first. So it has matched the dictionary. So there is in a dictionary what we have retrieved. There is in a dictionary that what we have retrieved, that is marked as a noun, that is marked as the first name, that is in masculine gender, and that is in genitive case. So we retrieve the whole entry, and then we put here its lemma. So F point lemma is now what is lemma in the dictionary entry of that recognized form. And now we have come to the last part of this presentation, and that is the cascades of graphs for named entity recognitions. What are cascades of transducers? As Eric has already said, and we have showed in the several examples, transducers are graphs that produce output. So graphs in a cascade have to be transducer. They must produce some output, otherwise they are not useful at all. And they can be used in two different modes. Output can be merged with the text, or it can replace the recognized sequence. And the cascade of transducers is just a list of transducers that says in what order are they used. The first transducer, the first in the list is used first, and it produces some output. The next transducer is not applied anymore to the original text, but to the output of the previous transducer. And it also produces some output, and it will be used by the next transducer in the list. In a cascade, all types of transducers that we have presented before can be used. Everything that we have presented can be used. Only the use of the left context is of no use. As I explained before, it is only important for the production of concordances. And what can be the output of a cascade? It can be whatever one finds suitable for solving one's problem. So whatever you think is suitable for your problem that you have. But for producing a named entity recognition system, it is useful if transducers produce output that is in the form of the lexical tag. A lexical tag is one type of a token in Unitex. For instance, in French, during the pre-processing, one usually recognizes aujourd'hui apostrophe oui and put it in a lexical tag. Why? Because aujourd'hui doesn't mean anything in French, oui doesn't mean anything in French, but when you put this together, aujourd'hui apostrophe oui, it is an adverb and it means today. In this case, there are no more, you don't have any more three separate tokens. You have one token, and it is why it is one token, one special token, lexical tag. How it works in transducers. Let's see that we have a sequence Bank of England, and one transducer recognizes England as an administrative location and replaces it with a lexical tag, Bank of, and now we don't have England as a word form anymore. We have a lexical tag, England, which says that it is now tagged as entity. It's not tagged as a noun anymore, but as entity, as a location, and as an administrative location. And it is put in the, you have this bank of lexical tag, England, as the output of that transducer. And some subsequent transducer looks for names of organizations, and one pattern for recognition looks like this: bank, lexical mask of entity plus lock, another lexical mask. And that pattern would recognize, bank would, as a noun would be recognized. Then you have the preposition of okay, and then it will recognize this lexical tag, England, because it has the markers entity plus lock. It recognizes that pattern and replaces now the whole sequence with a new lexical tag, Bank of England, and now after that you have the new tag, entity plus organization and enterprise, for instance. With this, we can obtain the embedded name entities, and they are recognized. For instance, this is from one French text from the French collection that recognizes one organization, and it starts with usine. Usine is the part of the name of organization, of this named entity recognition, name entity for organization, but then comes the proper name of the organization. It is du, and then we say the personal name because it's the factory that belongs to this person, and of this person it is recognized Marquis, that it's his role, nobility, then some linking de la and the surname Land. And in Serbian, this embedding would enable you to recognize something like this. In text you have Aleksandra Miloševića, učitelja osnovne škole Velizar Stanković-Korčagin iz Velikog Šiljegovca. And everything would be recognized as a person with his full name, his role, organization where it works, and the name and the place where this organization is situated. In text, it is all in the genitive case. And why are the embedded entities important? Because they connect recognized entities that are below. For instance, what do we know about this Aleksandar Milošević that we recognized before? First of all, we know that he is a teacher. Do we know where he teaches? Yes, he teaches at the elementary school, Velizar Stanković-Korčagin. And where is that elementary school? It is in Veliki Šiljegovac. So with embedded entities, we have already connected some elements of this recognized entities. For each transducer in a cascade, one has to specify whether it is used in a merge or replace mode. For instance, in a merge mode, enclosing recognized, we can put the enclosing sequence in XML tags. For instance, you have a telephone number and you want to tag it as a telephone number. You will put the XML tags for that, and then you use it in a merge mode. What you recognize, it stays where it is, but then you merge these two tags. But you can use it in the replace mode, for instance, to replace the recognized sequence with a new text. For instance, you have the same telephone number, but you replace this with one simple empty XML tag. Why is it, for instance, used? For anonymization. For instance, you would like to anonymize the text, so not to see the telephone numbers, the numbers of, for instance, social security numbers of people or something like that. But you want to put in a text that something like that was in your text, so you use it in a replace mode. A transducer in a cascade can be used repeatedly until reaching a fixed point. That is the point in which it cannot modify the text anymore. But of course, one has to be careful with the use of such transducers in order not to enter the endless loop. It's like in the programming, you have to be careful that you don't obtain the endless loop. For instance, let's look at this example. Text uses a tag M for emphasizing a sequence, and then an attribute type to say how it is emphasized. For instance, type can be I for italic, B for bold, or S for small caps. And these tags can be embedded. But we want to replace them so that we have simple tags with no type attribute, so that M will be replaced with tags I, B, and S according to the value of the attribute. So let's say that we have a text like this. So we have a text that is all in italic, but then inside that italic, we have also bold. And inside that bold, we have also small caps. And then we have a transducer that recognizes the starting and the ending M tag with a type that can have 3 different values, and it recognizes text between them that consists, for instance, for these constructed examples from the letters from A to J, and also these tags, but not EM tag. Only these tags that can that will replace the EM tags, and replaces these EM tags start and end with the new tags that correspond to the value of the attribute. So how it will work, this transducer? For instance, as a text, we have this, we explained that. And in the first run, this transducer will recognize only this, the most embedded sequence, because as we said, it does not recognize the EM tag. It recognizes it because it recognizes the start tag for EM, the end tag for EM, and these letters here, EF, are allowed, and it will recognize this. It will, as a result, we will obtain this same sequence, but now instead of this, we have EF inside S and start and end tag. Then we have the repetition of the same graph. It will now recognize. What will it now recognize? It will recognize the again the embedded tag, this, but it will consist of letters C, D, E, F, G, H. But as we said, it also recognizes these tags as start and end. So it will recognize this, and it will replace text with this. Now we have B tags that are where replace this EM tag. Then we have the third run of the same transducer. It will now recognize the whole sequence, and it will replace this first EM tag with I and the last EM tag with and I. Then we have the fourth run, but it's a fixed point. Transducer cannot recognize anything, so it will go on. So that's how this iteration mode works. And now the priority of some paths. In Unitex, the priority is always given to the longest match. You can change that in locate pattern, but if you don't change anything, it is always the longest match. Regularly, if you are outside of a cascade, all matches by local grammar are indexed, which means they are also listed in concordances. Since a transducer in a cascade modifies text, it has to choose between several possibilities, and it chooses the leftmost match. So regularly, if you are not concordances, it will you will see in concordances everything that is recognized. But here in the cascades, you will always choose the leftmost match. But you can also give weights to a path that match the exactly same sequences. When producing concordances, only line with the highest weight will be listed, but in cascade, since the transducer produces an output, if you don't put weights and you have several paths that recognize exactly the same sequence, it will choose some randomly. But you can put weights, and then the path with the longest, with the highest value, it means the first value, it will be chosen. For instance, look here. This is the graph that recognizes, we saw it before, first name last, and last name first. But if you have the name, for instance, Novak Milic, the both paths will match because Novak can be both first name and the surname, and Milic also can be both first name and the surname. But you, if you use it like this, then you don't know what will have for the output. The cascade with choose one path, you don't know which one. But you can put here, you can put weights, and here the weight one, the highest weight, is given to the path first name surname. Why to this path? Because it's the more usual way of expressing the full name, to give first the first name and then the surname. So Novak Milic, for instance, would be tagged as this. First, that Novak is the first name and the last name is Milic. Here are these weights. Then we have tagging generalization graphs. This is a special kind of graphs to be used in cascades, and they are very useful for named entity recognitions. Sometimes we recognize something in a text due to triggers. For instance, you have a Reka Sava. Here, Reka, we saw before, is a trigger, and it enables us to recognize Sava, and we tag Sava, which is otherwise ambiguous. But Sava in the same text can appear without any trigger. It sometimes appears with a trigger, but in other cases it does not. So you have the same form recognized and tagged properly, and then you have the same form that is not recognized at all. You can use then these generalization graphs that can be used, that have empty boxes, and program itself fills the empty boxes with forms that are automatically extracted from a list of tokens of a text that were previously tagged in a given way. You will see this example. At a certain point of the application of a cascade, we have recognized several inflected forms of Sava as rivers. So we have in a text, this, what is recognized, we saw before, replaced with the lexical tags. So Sava is named entity hydronym river. Savi is named entity hydronym river. Savu is named entity hydronym river. All in it is a mistake here. It's not, of course, masculine, but the feminine in several cases. But in text, there are still forms, Sava, Savi, Savu, that were not tagged. And we want to solve that problem. So we have a generalization graph. This upper is a generalization graph. So you put this special sign with this open parenthesis, and here you put what you want to generalize. So you want to generalize everything that you have already recognized and that has tags hydronym and river. And you want everything that was tagged like that, the same forms, but that were not recognized before. So this graph is automatically, you don't have to do anything. The program transforms this graph into this form and puts here Sava, Savi, Savu, because it was recognized before. And it will be tagged in the same way. It will be tagged in the same way. It puts here these negative contacts, just not to tag again what has already been tagged. But you don't have to do anything with that. It will all be done automatically. Why else are cascades interesting for named entities? With cascade, the recognition analyze is separated from the tagging synthesis. One cascade is used for the recognition and the other is used for tagging. Why is this important? This means that the different tags can be used for different purposes, not changing anything in the recognition process. So the recognition process is one for all possible outputs. So you want, for instance, to have annotation with or without embeddings. It depends on your what are you going to do with that. You just have to have a separate synthesis graph. So you want to skip some tags. For some recognized entities, you are not interested for them. So you just skip them for that purpose. This is an example of the analysis and synthesis. And this is a French text. We have already seen this text from the French sub-collection. And it had been tagged with the tags from these 7 tags from the that were used for level 2 coding. So you see tag OR for organization, pers for persons, role for roles, etc. This is distant reading named entity tag set. But then the same text analyzed with the same graphs, but using the same graphs for analyzing, then the other graphs were used for synthesis. And now you get TI named entity recognition annotation, more detailed, saying the organization name. Then you have, for instance, measures that were not included in the distant reading tag set, but you have here recognized some infra, and you have the appropriate tags for measure, for the type of currencies, for the quantity, for the unit use, etc. So you see much more detailed tagging, and also you see that there is embedding. For instance, Le Marquis Land, it was recognized. Marquis de Land, it was recognized as a personal name, but you have a separate embedded text for NOR, name, link, etc. And how can cascades be used? They can be used in the Unitex environment that you have seen in the morning, and you will see again. And this is a preferable mode for developers because it is easy to try and correct. You try, you see that something is not that done as you want it to be done. You correct a certain tag, certain graph, and then you repeat the whole process. But the Unitex commands used in the Unitex environment can be translated into a script, which subsequently can be used in the command line of the operating system. The script can be applied to a single file or to a collection of files in a folder. So it is the preferable mode for the end users. So the end user, for instance, if this script has been prepared by the developer, can just use the script in the command line of his or hers operating system and get the result for one file or for 100 files. It doesn't matter. So for the end user, it's perfect, because that means the end user need not know anything about Unitex, dictionaries, graphs, etc. Were cascades used for the named entity recognition systems? Yes. The French name entity recognition system that is called CASN, CASIS, that's the cascade system, entité nommée. It was used, and it was also used to annotate the whole French LTEC sub-collection. It is not for the production of the level 2, but it was used and produced the appropriate tagging. And it was also used for there is Serbian name entity recognition system with the acronym SERP-NER, and it was used to annotate the whole Serbian LTEC sub-collection, and for the production of the level 2, as you have seen at the beginning of this presentation. And is this all that can be said about Unitex? Certainly not. There is much more that can be said about graphs, transducers, cascades, etc. For instance, we have not mentioned various sorts of variables and how can they help in solving problems. So that can be, there are various sorts of variables and can be used in all sorts of ways to solve your problems. Fortunately, there is a comprehensive manual that can be downloaded from the Unitex official site. Eric has already given you the link, but here is the link again. And you can also read some articles. First 3 of them are about named entity recognition system for Serbian, and the remaining 2 are for named entity recognition system for French. But you have to keep in mind that we for Serbian simply, well, not simply, but anyway, use the cascades in Unitex environment, but Denis Maurel and Natalie Friburger, that are mentioned here in this paper, they actually, they are those that produce this system of cascades for Unitex. So this article should really be very important for you. And now this is can you see it? I suppose you can.
Yes, yes, thank you.
Okay, well, this is now the presentation that will just lead you through the steps that you have to do. I was a little bit afraid whether you will be able to manage it in 1 hour, but as I saw that you have more or less managed to do everything that Eric asked you to do, I'm sure that there will be no problems. Those that are on site will have the help from Biljana, and I don't know, Mihailo is maybe also there. So you will have a help, but I think that there will be no problems. So we will now make a small, very, very small named entity recognition system for English. So what you have to do, you have to start Unitex, but carefully Unitex, not Unitex GramLab. You have to choose English as the working language, and then you have to open the text. This is not the text that comes with the English, with the installation of Unitex. This is the text from the LTEC sub-collection. So you use menu text and then open this text. The name you see here on the screen. It is a text from the English LTEC sub-collection, Arthur Conan Doyle's novel, The Sign of 4. I just removed the header for easier manipulation for this exercise. There are still XML tags there, but the suffix was replaced with text, with raw text, because otherwise, if we open in Unitex the file with the extension XML, it will remove all XML text. We don't want to do that. So you start Unitex, choose English, and choose this text. Then you will be asked, do you want to pre-process the text? You say yes, but you uncheck all the other boxes. You uncheck the box apply graph in merge mode, apply graph in the replace mode. You also can remove dictionaries. So on this screen, you will get this screen. You want to pre-process, yes, but you uncheck everything that is checked. You just press the go button. And then we come to application of dictionaries, but just to be sure that you have chosen this text. Can I have some feedback?
Here, okay.
Here, okay. Okay. And now you have to apply dictionaries. Again, is the same menu text, and you choose apply lexical resources, and you have to check 3 dictionaries that have to be set by default. These are the name of dictionaries, and they have to be gray. The picture is like this. These 3 dictionaries. It doesn't matter if there are the other dictionaries that I have here. Maybe you don't have them, but it doesn't matter. You have to have these 3 dictionaries. Cas and ambiguities, Cas and insect deco, Della and public. That's all. If you don't have them, you have to choose them. Select and click. All 3 have to be gray, and then you put set default. So you want this to be your default dictionary for all this exercise, and then you click apply, and these 3 dictionaries will be applied to your text. If they are already in gray, then you have nothing to do, just press apply. And then we have to do the next step. It is the use of lexical mask. How do we proceed? Have the dictionaries be selected and applied?
Just a second, Cvetana, just a second.
Okay.
Can you go back one slide?
Mm-hmm. These 3 dictionaries have to be selected. They were one Della and public will be on the directory certainly, but these 2 are I have put them in this folder.
It is in this file, this folder. A sa jedno je da li su levo ili desno. To je sve jedno. Sad samo da su svi tu. Sve tu, sve ok. Aha, sve, ok. Da. Just to mention that it is same if it is in system resources or in user resources.
Yes, they have, but they have to be gray. And then if they were not previously gray, you have to put them to set default, so that this would be default for the whole exercise. But if they are already default, then you don't have to do anything.
And just click and shift.
Yes.
I'm sorry, I copied the files that you said, but it only shows Della and public, but not the other ones, even though they're actually in.
Please share your screen. Yes. And then
I can't.
It is copied somewhere else, probably.
It is probably copied somewhere else, and you haven't copied all files with that name.
Okay.
To right folder.
Yes, I think that must be a problem. I can't share because Cvetana Krstev is sharing, so it
Okay,
says
I
I
will
can't.
stop.
Sorry. Um, yeah, I don't. It just shows me Della in public. I
And
copied
show
it.
your directory.
Yeah, yeah. Sorry, I'm sharing the. I think I chose the wrong directory in the yeah, I think I have to play around with this because it's here.
It has to be in Della. Show me the Della here. So all this you have to put in Della directory under English.
Ah, okay. Ah, okay.
Yes.
Ah,
And
okay,
then
okay.
the public also. I don't know how you. No. Unitex,
Yes.
Unitex English. Where is that?
Yeah, I think I have a couple of stuff.
Unitex.
Ah, okay. But here it is. Okay, okay. I think I selected the wrong personal folder.
Or something, yes, something.
Okay, okay, okay. I'll try again. Okay, thanks.
Okay, I will share again. Has everyone else managed to apply these dictionaries? Ranka?
Yes.
Yes, okay. So now we can apply lexical mask. We use this lexical mask. So we want nouns that have this marker first name. That's the marker that's used for in English dictionaries. Now you know what you have to do. Open the menu text and choose locate pattern, but you put this lexical mask in a regular expression field. In search limitation, you choose index all occurrences in text that Eric already showed and press search button. So, just a moment. So this is a locate pattern. You have to put this in regular expression field. You have to put this lexical mask. You have to put index all occurrences in text. You choose till the end of the exercise. You choose that, and you press the research button, the search button. You should obtain all of you 391 matches. Then you press OK, and then press build concordances. It is very simple, I think. Once you have everything installed as properly, this is very simple. And I think that you will get concordances of these 391 matches. Do we have concordances?
Yes.
Yes. Okay, everyone has concordances, and now
Just a second.
okay.
Gotovi. We can continue. Thank you.
Okay, so now look at the concordances. You will see there are positive matches. For instance, Abdullah, Abel, Jonathan, and you will see many of them. But you will see also a lot of false matches. For instance, London, India, and even they are not names in this context. London is the name, but the name of the place, it is not the name of the person. But you know that it can also be the name of the person. For instance, Jack London, that's his name, but that's the person, not the place. Here we have only as a place, also India as a place, and as a article, even as I don't know, adverb or whatever. So this lexical mask is not enough. We have to have more precise queries. So we will make a graph that uses this lexical mask and this marker, but also the context. So now you open new graph, you know how to do it. So that's the menu, finite state graph, and the option new. And you produce this graph, this simple graph. So I will make you make only one graph, this one. You see it is not very complex, just a few boxes, not too many. And just to explain what do we want to do with this graph. We want to to recognize and tag titles. Then we put open. This is just a graph that makes an open parenthesis and recognize something that is maybe the name. Maybe the name is something that starts with the uppercase. We don't know that it is the name, but maybe it is. And then we tag that as a first name. Again, if it is followed by something that maybe can be a name, again, uppercase, starts with uppercase, that second recognition of something like that would be the last name. But the important is that for this part, there has to be a title. But if, that's the second part here, if there is no title, but we as a first have something that has the marker, the first name, that we don't have to have a title. Maybe we will see what we will get. Maybe there need not be a title. We will take it as a first name, and then what follows, maybe the name that we will tag as a last name. Here you will use some subgraphs, but these are already prepared. You will not have to type them. You just have to invoke the subgraphs. You already know how to do that. You have to type in a box a colon and then the name of the graph. In this case, one is just the name is B, the other is TTL, the other is maybe name. Until you save your graph in the same folder, that will be the same folder as for any, in which the graphs are stored. They will be red. When you finish your graph and save, they will turn gray. And then you want to make a lexical tag out of the recognized sequences. So you have to put this output in your graph. Eric already explained how you have to do that. So you have to have this empty symbol, then a slash. After slash, everything after slash is the output. For the beginning, you have just the open parenthesis or the invoking of this graph B. And then the end of the lexical tag, when you put how you will tag this. For instance, for the first name, you will put first. For the last name, you will put last. And then you can also put the name of the graph. For instance, in this case, I put just GRF1 because when you are seeing the results, sometimes if something is not correct, you would like to know which graph tagged something so that you can look and correct whatever that's good for the control. So this is again what you have to type. I think that after this morning session, you will be able to tag this, to make this graph. And I will wait. I don't know. 5 minutes. I think that 5 minutes will be enough.
Mi smo se slikali s ovim, ovi su otišli u Litvanci.
Kako se niste slikali?
Sad su otišli.
Joj.
Otišli su avion, imaju popodne. No, nisam znala da ću doći. Mislila sam na pauzi za ručak da se slikamo, a oni su samo su sad na pauzi. On idu za mnom.
Ne baš šteta.
Advancing here. In front. In front.
And those that are remote, how do you proceed? Tamara, do you manage?
No, I don't know what happened. I guess there is something wrong with the directories. I have all the files, but it's still not showing the correct lexical resources.
Probably it would be better to copy to folder that you previously had that used as a home directory.
Yes, I think I have several subfolders that I should not have created, and now it's kind of confused.
It's
I have several folders.
Yes, it's
that say TS Belgrade, and they have like subfolders. So I guess I'll just will the recording be available? So can I just watch it and try it out afterwards?
Yes, maybe it's best.
Okay.
And if you have some problems, you just write to me, and I will help you.
Okay. Thanks very much. I think I'll just try it. Like,
yes, probably it's the best. You just listen
folders.
now, and then when you solve this problem with the directories, then it will work. You will see it. It's really very simple exercise.
Great, thank you.
It's really difficult with this. I'm here, they are on the other location, and the others are who knows where. So it's very difficult to control.
Cvetana, can you show your Unitex environment for your home directory, how is organized? Maybe this was not clear to students.
My Unitex directory.
Yes. What is corpus, dictionaries, cascades, that part? Maybe they
I
need-
have, you see, you have, I have under my directory. Do you see now?
No.
You
No,
don't see.
it's still it shows the
see,
PowerPoint
presentation.
presentation.
No, you see my presentation.
Yes.
Oh, so I will.
Okay, maybe if you want, I can share the one, not mine, but on this computer.
Okay, you share. Maybe it's better. I have stopped sharing.
So here, just let me organize a bit. So here, for example, are Arabic and English only. So here would be all other languages. For each language, you have these alphabets and some other configuration files here. Here is a list of system dictionaries, but nothing important. Here in DELA are expected these dictionaries, user dictionaries. From corpus, it reads by default open text, and Cassis files comes here, and
graphs.
Graphs. So these are important.
And
things.
then Ranka, go back to graphs. Then you have repository. Then you have TS Belgrade. And here you have all the graphs that you have to have. So it means language, graphs, repository, TS Belgrade, and then all the graphs.
Okay, and all of this should be under English, right?
Under English.
Yes.
Ah, okay, I think that was the
Here you can
problem
see-
because, yeah, okay.
Yes.
I think
here
in
you
my
can see
case,
Unitex
English was
English.
under, okay. Sorry.
But this Unitex, this is not a program. This is with data. You have other directory which is Unitex with program files. So this is data files here.
Ah, okay, maybe that's the problem. Okay.
Cvetana and we are using my Unitex to make a difference between what are binary files for Unitex as a program and data resources. Okay, I will stop sharing.
And has everybody else, I will share again.
Yes, please. Se uspeva. We are near, not still on target, but near to target.
Okay. It would be good if the persons there can make just this one graph. After that, we will only use the existing graphs. Just to.
One is good.
Okay.
Milos has succeeded.
Excuse me, I have a question.
Yes.
So what should I do for my maybe name B stuff to become gray and not be red?
You have to save your graph with the. We will come to the point of the saving the graph. Just make this graph for the beginning. Let them stay red, and they will turn gray at the next step.
Can I share my screen so that I'm sure that everything is okay?
Okay, you can. I will stop sharing.
Okay. Do you see?
Just let me see. I'm sorry, it's very
tiny.
It looks very much okay. Yes.
Okay.
Yes. Okay.
Good. Thank you.
Okay.
We can continue.
We can continue. So just a moment. Okay. So you have produced this graph, and now you can see. You can't see now before saving. We will return to this. Now you can save this graph. You choose your name, whatever you want, but you have how will you save it to turn these all boxes not to be red but gray, turn them gray. So first a graph is a menu, save as, but when you save you have to use the folder graphs, repository, TS Belgrade, because all the subgraphs, everything that we will use are already there. So you have to save, you use whatever name you want, and you save there. And just tell me, have your boxes turn gray?
Mine have.
Okay. Okay. If they have turned gray, then you can see all the subgraphs. Now we want to see all the subgraphs. How you see the subgraph? You just use Alt and click on the box where the subgraph is, and it will open. And you can do that or not, whatever you want. You can just try to see how it works. But then what is the content of these graphs? This is simply the graph for titles. There is nothing that you haven't seen before. So there are some titles here that I found are used in this text, Miss, Captain, Major, and so on. And then there are the others that use obligatory stop point after, they use point after, and that's recognized by the title. What is recognized by maybe name? The maybe name is used for, this is something you haven't seen before, but then you will have to look at the manual to see how it works. But it is simply for using the regular expressions. So what we say here under this double.
Cvetana, please, just a minute or two.
Okay. Can we continue?
Biljol, možemo? Yes, yes, yes. Thank you.
So you see here the subgraphs that you can open with Alt plus click or just look at what it is. Here we have explained there is nothing for titles, nothing that you haven't seen with Eric this morning. Maybe name is the special usage of these are called morphological graphs. So you can use the pattern for a token. Just a regular, normal, regular expression. It says in these double angle brackets that at the beginning, this token at the beginning has to have an uppercase letter followed by at least 2 lowercase letters. And then that's maybe, we say that's maybe a name. The graph B is special. I will not enter why it's written like that. It's just to be sure to have between recognized text this blank space. Okay, you have saved this graph under some name. Your boxes are gray, and now you can use the subgraph. You already seen how to do that with Eric. So text locate pattern, but now use this graph for search. Use this graph for search. You will have this this on the screen, locate pattern, but now you use the graph. You see it's not a clicked regular expression by graph. And it has to be, as I said, English graphs repository TS Belgrade, and then you use your graph. Here I have used my graph, but you will use your graph. You are not grammar outputs at this moment, you say, are not taken into account. And of course, you have index all occurrences in text, and then you press search. If you do that, you will obtain some 96 lines. If you have typed everything correct, you should get 96 lines, and you will see that some are okay, really names, and some are not. But it is not the point now. Point is to obtain 96. Have you managed to do that?
Here, yes.
Oh, wonderful. Do we have some more? Yes.
Some yes, some no. Just a second.
If some of you do not obtain 96 lines, then because we don't have time now to correct your graph, something was wrong in the graph probably, then you will just use this graph that I have, that's the graph you've seen on the screen. Then use this graph just to obtain this 96 lines.
Yes, that would be now good to use the prepared graph from.
Because we don't have time to correct the errors. You can look afterwards to see what was wrong. Use this graph that was already prepared. But I see that some have been successful and obtained 96 lines. If everybody has done that, just look at the concordances, and then you will see that you have some good examples, and then you have some not good examples. I mean, not personal names. That it's not the point now. And if you have managed to do that, then repeat the whole process, but just change the grammar outputs and put merge with input text. Just change that and click search, and again produce concordances. And if you do that, you will see now that now you obtain lexical, or you obtain lexical tag, lexical tags. Yes, not you. It's not recognized anymore. Abdullah Khan, just like that. It is lexical tag Abdullah first, and then the next lexical tag Khan last. Have you obtained that?
Here, yes.
Oh, wonderful. And what happens in the classroom, Ranka?
Working hard and everything fine.
Everything fine. So we can continue.
Yes, please.
And now we proceed with graphs that try to recognize as many as possible correct names as possible. Well, these graphs are already prepared, so we will not make the graphs, we will just use them. How we will use them? We will use an already prepared cascade. So now you have to open the cascade. What is cascade? It is the list of graphs. So now you again use the menu text and use the option apply Cascades cascade. Select the cascade for the analysis. It will appear because nothing else is there but two cascades, one for analysis that you will use now, and press the button edit, because now why edit? Of course, we will not edit it, but because we want to see what is in this cascade. You will obtain this. You have to obtain this. So open text menu, open apply like Cascades cascade, choose the one for the analysis, that's this one, TS analysis, and then press the button edit. You should obtain the screen like this. Have you obtained the screen? Okay.
Yes, yes, you can continue.
Yes, and now, what do you have to do now? We look at the next graph. The first graph we have already seen. That's the one that we have seen on the screen and that you have prepared, some successfully, some not so successfully, but anyway, prepared. So we know that what this first graph does. Now you want to see what does the second graph do. You have to select this second graph, but be careful not to disable it. Just select it and press the button view, and you will see the graph. This should appear on the screen. So just select and view, and this should appear on the screen. Have you managed?
Yes, here mostly.
Okay. So we have here, I can continue.
Just a second.
Mm-hmm.
Is that wrong? Ana, jel si dobila? I think you can continue and
This should be really easy. Select the graph, view, and you receive the graph. So this is
just if everything is in the right place. If something
yes.
is not in the right place, then
Yeah, then it will not. That would be the problem. So this is the first generalization graph, generalization graph for the first name. So if in the previous step something was recognized as the first name in a broader context, for instance, it has a title or it was followed by the something that may be a last name, we at this point assume it was correct, and we take all occurrences of the same string to say as the first name as well. That's what this graph do. That's the generalization graph that generalizes this words, let's call them that way, it's the easiest way at this point, that were already recognized as first names. So everything else that's the same words will be tagged as a first also. So now we can apply, otherwise we will not see what has to be done. We have to apply the cascade that performs the analysis, that recognizes and tags names. How to apply this cascade? You have to press the button close to close this edit view. Again, select the cascade analyze and press the button launch. For a short time, it will work something and then finish. Have you managed to do that? Have you managed to launch the cascade? Ranka?
Not everyone.
It's very easy. You go to...
Okay.
You launch the cascade. And now comes what you want to... you have launched the cascade. That cascade has done whatever it has done. But we want now to see what has it done in the first and the second step, just in the first and the second step. So the cascades always produce a number of intermediary files. But these intermediary files are very useful when developing cascade, because then you can see what each graph has really done. If there is some error or something like that, you can see where this error actually happened. So now you will open two intermediary files. To do that, you go to text menu and then choose the directory. You see, it is not the text, it is directory. The name of the whole name of the file, and then underscore CSC. And then you choose the file, and then you choose the file, not the directory, but the file with this _1_0. It means the first iteration of the first graph. So you will see the text, how it looks like after the first graph. If you have the problems, I will stop sharing the presentation now and open my Unitex just to see. I'm sorry. Share just to see where is. No, here. And So how to use this? Text, text. Look at the screen now. Text, then open. And then you see here, English, blah, 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 Doyle, no header, underscore XML, underscore CSC. And you see that it is a folder by this icon at the beginning. You click there, and then you see some text files. You use the first one, not the first one 00, but this one 10, and you open it. No, it's not. No, I'm sorry. You see,
Not folder,
I got confused. Or you have to check to put these all files, and then all files here when the folders stop, the files begin, and you choose this one, 10, 10, and open it. Have you managed to do that? If you want, I can go to the whole process from the beginning.
I think it's fine. They can see it.
Yes. So that's the result of the first graph. So I now use the locate pattern. I'll now use the locate pattern and type here lexical mask first, so to see what was tagged as a first name by the first graph. Search, I obtain 41 matches, and I can see also what are these. Something just a moment, I'm sorry. 41 matches, but then you will open the next file. So not 10, but 20. Open 20 and use the same pattern with 20. Locate pattern, the same, and you will obtain 96 matches. So what does it mean? It means that the system has generalized. First, with the context, it has recognized the 41 as a first name, and after the second graph that generalized the first names, so it recognized also the same strings, but that were not in that context, didn't have that context, also as the first name. So now we can go back to the presentation. And if you have done this and obtained whatever was needed, we can now proceed with the cascade, just to see what are in the graphs that follow. You don't need to open them now, because we will just lose time if you open them all. It's the same as we have seen. You open the cascade, you choose the edit, and then you have the list of graphs. You select the graph, press the button view, and you will see what you see here on the screen. The third graph in the sequence is the same as the previous, but it just generalizes last, what we have tagged as a last name. It's otherwise it's the same. Then we have the graph called purse. Now we tag as a person everything that we had recognized so far. Everything that we have recognized so far. We want to make a tag person that will tag a title, first name, last name. So it will put together title first, last, title last, title first. So you see all those parts. Title first, last. Then you have title only last. Then you have title only first, and so on. And it will put a new tag that is person. So it will be done by the fourth graph. Then you have the fifth graph that now tries to recognize what is left. So we had the full name, first and last, and now we try to do the names that have just the title, but then the title is obligatory. The title is obligatory, and maybe name. Title and maybe name. So if we have titles, then it means certainly something from the list in this subgraph, and tag this title, and then maybe name tagged. That means something that may be a name, tagged as last name. Okay, that is done by the fifth graph. And at the end, you will see that you have the graphs that were already used. So the graph that generalizes the last name, and the person graph, the same graph that again puts together all the elements of name data. Nothing is said that you cannot use the one graph several times. If it suits your purpose, you can use the same graph several times in a cascade. It's completely okay. And what has been achieved? Now, because we already used the graph, you can open the results of a cascade. Now you have to go back to the corpus. Because we were looking at the intermediary files. Now you go up again, to say like that, up back to the corpus folder. So text, a menu, open, and then you choose this graph, the name of the file at the beginning with the slash CSC. That means this slash CSC, that means that it is the result of the cascade, and then the version row, because you have two versions, you choose now the version row. You will be asked, do you want to pre-process the text? You answer no, because this version of the result uses lexical tags that human use for the search. So you will use text, locate pattern, regular expression, and tag purse, and you will obtain exactly, by chance, exactly 600 matches, and you can produce concordances to see what is there. I will go now again to my Unitex window. So you see, you will go with open, you will go up again to the corpus, to the corpus folder, and then you will choose the text. So no, I have here much more folders than you. You will have to choose. So which one? Something with Doyle, no header, Doyle, no header, XML _ CSC row. CSC row, you say open. Do you want to pre-process the text? You say no, and it will appear. You will now use locate pattern, and you will use purse because everything was put in a purse. And you say search. But I want to have all occurrences. Locate pattern, all occurrences. Here are 600 occurrences. And you see them. So here was Hope, Tadeusz, Abdullah Khan several times, and then just Abdullah, just Ahmed, and so on and so on. So you will obtain something like this, 600. Of course, you see that there are some occurrences that are not correct, like Baker Street. And why was this put incorrectly? Because Baker is also, of course, also the first name. And the street in English, it is written in uppercase. So that's a false recognition. But you should obtain something like that. Have you managed to do that?
Yes, here.
It was not very difficult. But now, when you have obtained that, you open again your text. You open again the result of your concordance, but now the other version of the result, which has the extension txt. It is placed here, so you will not have any problems to find it. The same result of the concordance, but the version txt. Open it. You don't want to process this. You obtain some other result, but why is it important? You can use now the second cascade. You can use the second cascade that will produce XML tags, more or less something that you would expect at the output. So the second cascade, you use it on this version of the text. If you have managed to open this text, have you managed to open this text?
Yes.
Yes. Now you apply the second cascade. The second cascade. Apply this cascade, but now you use the second one, synthesis. The second one, synthesis. You don't need to look at it. It has some three graphs. You can look at that later. You just launch it. And this cascade has done something. Usually, I open the result in the Notepad ++ because it's the easiest way. But we will try to open it. If you have done this, have you done this?
Yes.
Yes. You can open open here, text files. So you open now which file? Again, you have to skip these folders and come again to your Doyle no header XML. But now you choose this one that has two CSC because the first one goes for the first cascade and the second one for the second cascade. So you open this with two CSC, open it. And what you see, fortunately, at the very beginning, you see after the chapter 1, the science of deduction, you see Peirce tag, and then first tag Sherlock, and the last Holmes, and then the end of the Peirce. So Sherlock Holmes was appropriately, you see, with what you expect, the XML tags, you obtain the XML tags. So if you go somewhere, you see here, for instance, you see Jefferson Hope. It was also tagged in the way you would expect it. Have you managed to obtain all this?
Really. Yes, more or less, yes.
Okay, then we will just see the last few slides, just the conclusion, because that's the so we have done all of this, and you obtain this result. You obtain this result. For instance, Miss Mary Morstan, you can see in your results that Miss is title, Mary is first, last is Morstan. But if you go through your text, you will see that there are in this case, quite a number of false recognitions, and many of them can be avoided. Of course, this was just let's say a toy cascade, not a real one. First, dictionaries have to be improved. Here we don't have very elaborate English dictionaries, so they had to have more proper names with more refined markers. But even without that, much can be done. You can notice that there are a lot of urban places mentioned in these novels. So these urban places use appropriate triggers, street, square, etc. And if you make the appropriate order of graphs, you can move a lot of ambiguities. So you can use first, for instance, use before saying that something is a person, you can say, okay, I recognize, I have a baker as a first. I have baker as a first name. And if it is followed with the street, square, etc., then I will not tag it as person. I will tag it the whole sequence as, for instance, urban place or something like that. And also there, for instance, they mention this novel, island, isles, and so on. These are all triggers that even if you don't have a very elaborate dictionary, you will be able to avoid a lot of ambiguities or these false recognitions. So this exercise session was prepared to give you just the impressions how things are done and what can be achieved. There is, of course, the comprehensive manual to help. There is also a Unitex forum that can answer your questions. And of course, both I and my colleague Denis Maurel, we are available to answer your questions or to give you help if you want really to produce some useful cascades for named entity recognitions for your language. So that will be the end of this exercise session. I hope that it was more or less successful, but you have slides, you have materials, so you can try all that at home when you are at ease and not pressed under pressure like here. And I'm sure that everything will be much more clear.
Thank you very much. Thank you, Denis. Thank you, Eric. Thank you, Cvetana. I think that it was really very hard to put in such a
Yes.
short time such a powerful and complex tool. But I think that our trainees get an impression and starting information and instruction for continuing to exploring GALTEC collection using Unitex. Thank you very much.
Thank you.
And now we shall have a break and see you all in half